Hello all, I would like to give a very quick introduction to the course on digital image processing. Myself is Mahesh Panikkar, Associate Professor with Electrical Engineering. So this is the details, a high-level overview of the course. It is a five-level course, and it's a three-credit course with a credit distribution as 2023, which clearly shows there is a significant amount of hands-on associated with the course. So whatever we are learning in the course, we will have a hands-on associated with that. So there will be some programming exercises as well along the course, and we do have pretty much every week hands-on session as well. So the mode of lecturing will be something like 2 live lectures and 1 hands-on, and there will be also recorded videos shared with you so that you can always refer back in case you missed out on the live section. And on the requirement side, prior exposure to digital signal processing will be always plus, because some of the concepts in image processing is basically extending concepts from 1D to 2D. So if you're comfortable with signal processing, you will be having an easy run in the course. But having said that, most of the topics I will be starting from scratch, and even if you don't have exposure to signal processing, most of the topics are sort of easy to follow. A knowledge of Python is mandatory because all the programming assignments have to be submitted in Python. Even though I will be showing both MATLAB and Python, the preferred mode of coding in the assignments is Python.
So what's inside? That's very important, right? So I've just broadly classified this into 4 buckets, starting with digital image fundamentals, then image enhancements, then image segmentation, and then finally computer vision. So when I say computer vision, it's not really all the basics for computer vision, but just a gradual introduction to a very, very quick introduction to computer vision as well, because any modern day digital image processing course without touching upon computer vision will not be doing any justice. Okay, so what is there inside each of these 4 sort of broad topics? So when we say digital image fundamentals, we start with the physics of vision, because we all know that image processing, as the name suggests, is all about processing of images, and mostly natural images. And for all those images, whatever the processing that we do, whether it is working or not, it's purely based on the human perception, right? So the understanding of the eye, the illusions created by the brain with respect to vision, all are important. So for example, in this image, which is actually, if you zoom in and see this image, it is a grayscale image, but I put some vertical lines, as we can see over here. Those lines gives the intuition that, or the illusion that, this is a color image. So we'll understand why this happens and so on. Then we also talks about some fundamentals, like histogram, for example, is a very powerful tool that is useful in images. So just to give an example, the image on the left that I'm highlighting here is actually something which is very low contrast image. So by doing a simple histogram adjustment, we call it as histogram equalization, you can actually sort of improve the image to a large extent like this. So you can see here, these regions which were not really clear became very clear here. At the same time, some regions get saturated. So we can do better than this, but all these techniques you will learn during the image processing course. And then of course, the fundamental operations like rotation, translation, scaling, sharing, etc., all the affine transformations we will discuss. And these operations are extremely important if you want to work on something like augmented reality or virtual reality. Then moving on, the image enhancement side, this is where we start to look image different from the spatial domain perspective. So we will go to something like Fourier domain. We will try to see the magnitude and the phase in the image. For example, as in this case, we take the magnitude of the image and then combine with the phase of this image, we'll get something like this. And the reverse is also possible. So it may not look very interesting to you at this point, but this is extremely useful when we talk about something like image blending, where you can fuse 2 images together cleverly. Okay, so another example is the filtering aspect. So we'll do lots of filtering. In this specific case, this is an X-ray image of a PCB, which is corrupted by something popularly known as salt and pepper noise. And if you apply any low pass, band pass, or high pass conventional linear filters, this is not going to improve. So what we need to do in this case is something like a median filter, which is a non-linear filter, and you get a very clean image. And you can imagine, if you are having such an image, moving on to this image, how much extra information that you can extract from the image. And having having said that, this is extremely important to understand what type of noise that the image is getting affected with, and all those things you will be able to understand by the end of this course. And then another interesting case is like downsize or sizing, or the increase or decrease of size of the image, extremely important, because most of the time we do that. And if you don't do it cleverly, then you will end up in trouble. For example, in this case, it is just downsizing the image by 2. Okay, so there is no sort of filtering or anything which is applied, just simply downsizing the image. And you can see that in this image the lady is sort of sad, and in this image the lady is sort of smiling. So this is known as aliasing, and it is actually distorting the image. So we have to be careful. So we'll talk about the intricacies, the things needed before you even downsample an image. So it's an example. So it comes under the image enhancement. And as I told, if I have two images, let's say a person and a sort of buildings, if I want to fuse that image with the person in the background, we need to talk about image blending, and you will thoroughly understand the blending aspects here. So compression and blending are two important image enhancement applications that you will learn in this course. Moving on to image segmentation, and this is where the entry point to computer vision is all about. As the name suggests, computer vision is nothing but trying to make sense out of the image, right? Till this point we were talking about sort of purely processing the image, improving the image, but now we will talk about trying to identify what is there in the image. So fundamental step in that direction is segmentation. So segmentation just means you take the image, divide it into different segments. It can be foreground and background as simple to start with, or it can be extracting the edges to start with. So in this case, I'm talking about the edge extraction using popular techniques like canny edge and so on. So you'll discuss all that in this course. Moving on, there's something known as intensity segmentation, where I can purely use some thresholds to come up with image enhancement. For example, this is very common when we take images using our cameras. Most of the time the light intensity will have a structure like this. So this is a periodic structure. You may be able to actually remove this, identify these masks, and then try to remove that using local thresholding, commonly known as outsource thresholding, and you will be able to come up to and a very clean image like this. So you might have used an app in your mobile to actually develop or use or process the image like this to give an image like this. Now you don't need those. You can actually do by yourself after you learn this course. And then of course, this is the image segmentation I was talking about. Given this image, I need to extract all the important segments in the image. For example, the cameraman, the tripod, the grass covering, the building, the clouds, everything will be like different segments in the image, and those are beautifully captured here in different colors. So we'll try to come up with these algorithms. These are not the modern day neural network algorithms. These are the traditional classical image processing segmentation algorithms, where we will discuss these aspects in detail. And then last but not the least, as I said, we will conclude with a quick introduction to computer vision. And I will introduce to you two fundamental concepts. One is known as stereo imaging, where we will have multiple cameras. And if I take the different pictures of the scene, I can stitch them together to come up with something like a depth image. So those are heavily used in our modern day mobile phones, or in sort of autonomous cars, where you need to gauge the depth in front of you, right? So 3D image from 2D images. So something like that is known as stereo imaging. And then optical flow is a very powerful concept, where if you have subsequent images, let's say I have a video recording, then I could use subsequent frames to sort of estimate the motion between the frames. So very powerful. So for example, here, if I zoom in this image, you will carefully see the direction with the cyclist is moving. His body part is moving in some direction maybe. So that things you can easily capture in this particular task. So this is the slide which actually sort of elaborates what I was talking about in lot of details. So you can pause and see the exact details of each and every module in this course. And the textbook that we will be following fundamentally is the Gonzalez textbook, which is considered to be the Bible of digital image processing. And yeah, that's pretty much the quick introduction is all about. So if you have any questions or queries, please feel free to email me. I will be happy to explain to you. Thank you for listening.